Hello students. Now let us discuss the third problem, which is what angle should be a ray of light incident on the face of an equatorial prism so that it just suffers a total internal reflection at the other face. The Ri of material of the prism is 1.5. So one prism ಕೊಟ್ಟಿದ್ದಾರೆ ಅದು equilateral prism, that means angle is 60 degree. So here is 60 degree and refractive index of the material of the prism is 1.5. See, here in this question we can cover three things. One is Snell's law, another one is critical angle, another one is total internal reflection. Okay, so ಇಲ್ಲಿ total internal reflection ಯಾವಾಗ ಬರುತ್ತೆ when, see, in this interface this will be normal. Okay, at a certain angle ಅಲ್ಲಿ incident rays hit ಆಗಿದೆ to this surface and it will refract to this direction. Okay, so again ಇಲ್ಲೊಂದು interface ಸಿಗುತ್ತೆ. So total internal reflection ಯಾವಾಗ ಸಿಗುತ್ತೆ when it is more than the critical angle. So critical angle ಯಾವಾಗ ಸಿಗುತ್ತೆ ನಮಗೆ when the refraction angle, or here in this prism case emergent angle, is 90 degree. Okay, so here emergent angle is 90 degree means the ray will go to this interface, right? Then this angle will be considered as critical angle. So now to find out the angle of incidence, see here they asked what angle should be ray light incident on the face, right? That means to find out this angle of incidence, first we need to know critical angle, or at least we need to find R1. Okay, so here in the theory class we consider this angle as R2, right? So here it is critical angle, just to find out the incident angle at total internal reflection. Okay, so first let us write given datas, which is refractive index of prism, that is 1.5, and refractive index of air will be 1, and apex angle of the prism, or A, is equal to 60 degree. Now we have to find out the angle, incident angle, and total internal reflection angle. So from the Snell's law, let us find out the critical angle. Okay, at this point. Okay, consider this one as PQ. So at point Q, we have to apply Snell's law, that is sin I by sin R equal to N2 by N1. So here in this case, the light ray is moving in this direction, right? At this interface, N1 will be this prism and N2 medium will be air medium, right? So apply here, the angle of incidence is critical angle in this case, divided by sin R is 90 degree, which is equal to N2 is air, which is 1, divided by N1 is, see, N1 of the given prism is 1.5. So sin IC is 1 by 1.5 because sin 90 is 1. So critical angle is 41 degree. So now we got the value of critical angle. We have to find out R1 value. For that I will use this formula, which is A is equal to R1 plus R2. Here R2 is IC, that means A is 60 degree, this angle, So R1 plus R2 is critical angle. Critical angle is 41 degree, which is 41 degree. That means R1 equal to 60 minus 41, which is equal to 19 degree. Okay, this is R1. Now we have to apply the Snell's law at this point, because we have to find out this angle, incident angle. So Snell's law, or apply Snell's law at point Snell's law at point P, which is sin I by sin R equal to N2 by N1. See, in this case, this one will be N1 and this will be N2. This is N1 is air medium and N2 is glass medium, which is 1.5. So apply that here. So sin I equal to N2 is 1.5 divided by N1 is 1 into sin R is sin R is 19 degree. Okay. So 1.5 into sin 90 degrees, sin 19 degree is sin 19 is 0.294. So which is equal to 0.441. So sin I is 0.441. That means the angle of incidence is sine inverse of 0.441, which is 29.07. See,